One of the most significant sources of radio radiation in the whole cosmos, Betelgeuse delivers more energy than a billion suns and would stretch to the orbit of Jupiter if placed where the Sun is. It is a monstrous object that is utterly unsteady and about to explode. Betelgeuse is a red supergiant star that, if placed where the Sun is, would connect with Jupiter's orbit, making it monstrous, completely unpredictable, and likely to explode. When we think of stars, we usually picture small, glowing objects in the night sky. However, one of the most prominent stars is much larger than our Sun. For many years, this star has baffled scientists, but something even more concerning has been happening with Betelgeuse, making astronomers and other highly educated people extremely concerned. Join us in this video as we explore the amazing news about Betelgeuse, its impending obliteration as predicted by the James Webb Space Telescope, and how this new development will affect our universe and our lives here on Earth, as explained by physicist Michio Kaku. The reddish-orange star, which is located in the upper left shoulder of the Orion constellation, is an ancient and possibly one of the most brilliant stars in the night sky. However, one of the great qualities of Betelgeuse is that its brightness fluctuates rather than remaining constant. This fluctuation is one of the star's many remarkable characteristics. The first person to discover Betelgeuse was the Greek astronomer Antonius. The star is so massive that it can be seen in the night sky from Earth, especially during the winter. If you're interested in cosmology, you've probably seen or heard of the star. The majority of the stars in the night sky are far from Earth. The closest star is 4.2 light-years away. If you don't understand how the term light-years conveys distance, visualize it this way. Imagine traveling at the speed of light for an entire year. It has been demonstrated that light can travel 186,000 meters per second, meaning that the distance light can travel in a year is equivalent to 1 light-year. If you calculate the distance, you'll get billions of miles. Now consider that some stars are much farther away, and Betelgeuse is one of them. We can't move that fast, not even our fastest space rockets can, but even though Betelgeuse is located roughly 600 light-years from Earth, it would still take 600 years to reach it at the speed of light. If you're wondering how Betelgeuse can be so bright despite its distance, it's because of its special characteristics like size and luminosity. The radius of Betelgeuse is thought to be about 1,000 times that of the Sun, making it many times larger than the Sun. Unfortunately, when seen via contemporary telescopes, it appears as a disk in space, and different stars appear as tiny points of light. This is believed to be the consequence of interactions at the outer layers of its atmosphere. Betelgeuse weighs between 12 and 19 solar masses. The standard unit of mass used by astronomers is a solar mass, which is equivalent to 2 times 10 to the power of 30 kilograms. Since there are no other planetary bodies orbiting Betelgeuse to compare its mass to, and because we cannot measure it directly from Earth, scientists are unable to determine its exact mass. In simpler terms, Betelgeuse is many times more luminous than our Sun, which explains why it was given the nickname Red Giant. However, Betelgeuse's brightness fluctuates due to its pulsations. As it expands, it becomes brighter, and when it contracts, it dims. This cycle may continue for 10 to 100 days, or even longer. One of Betelgeuse's special characteristics is that its surface is covered in dark magnetic spots, which make the magnetic field much stronger than it would be at a normal surface. On the downside, though, these powerful magnetic spots prevent hot gas from flowing to the star's outer surface, making the star colder in these areas. Although the Sun has its own black magnetic regions, they are far bigger and much more numerous than those on Betelgeuse. This helps explain why Betelgeuse is cooler than our Sun despite its size and brightness. In addition to having spots that may be twice as big as Earth, Betelgeuse has a magnetic field 10 times stronger than the Sun's, which explains why the gases on its outer layer seem to be in curves or circles when seen through a telescope. The low surface temperature of Betelgeuse, which is around 3,500 K, is what gives the star its distinctive red color and poor energy. Betelgeuse is a red star, but it wasn't always red. About 10 million years ago, it was yellowish, much like our Sun. Over time, the color changed to orange-red, and then, about 100,000 years ago, it gradually began to change into the red star we know today. This fact has led scientists to believe that the star is maturing because Betelgeuse produces up to 100,000 times more energy than the Sun. If it weren't so far away, it would have been a serious contender for our Sun. It is remarkable that the 600 light-year distance Betelgeuse is still visible at night with the unaided eye. Because of its immense size, Betelgeuse would consume or displace Earth and the other 4 nearby planets if it were to replace the Sun. In addition, even if it were to match the Sun in size, it would still emit more radiation. Our Sun is only 8.3 light-minutes from Earth, which is why it is so powerful. If Betelgeuse were only a little bit closer, we could also see it during the day. Located in the constellation Orion approximately 600 light-years from Earth, Betelgeuse, also known as Betelgeuse, is a very giant star. One of its most remarkable features is its enormous size. It has a radius several times greater than that of our Sun and could easily enclose Jupiter's orbit if it were positioned at the center of our solar system. Because of its legendary size, Betelgeuse appears as a disk rather than a point of light when viewed through powerful telescopes, unlike most other stars. Its mass is between 12 and 19 times that of the Sun. The difficulties in accurately determining the mass of stars without partner stars or other objects to serve as gravitational reference points, even at their reduced estimated mass, are the cause of this variance in mass estimations. Betelgeuse is still a massive celestial body, and one of its other essential qualities is its brightness. Its brightness varies steadily over time, ranging from magnitude 0 to plus 1.6. For reference, a star of magnitude 0 is around 2.5 times brighter than a star of magnitude plus 1, and at its brightest, Betelgeuse may be up to 1,000 times brighter than our Sun. This fluctuation results from the star's internal activities, which allow its pulsations to occur intermittently. When Betelgeuse expands, it grows brighter. When it contracts, it dims. Its dynamic look in the night sky is enhanced by the fact that these pulses might continue for months. At around 3,500 Kelvin, Betelgeuse's surface temperature is comparatively low for such a massive star, giving it the characteristic crimson hue of red giants reaching the end of their life cycles. In the final stages of its evolution, Betelgeuse has started fusing heavier elements after depleting its hydrogen fuel. This process generates energy and causes the star to expand outward. Its atmosphere is full of complex physical phenomena, and it exhibits dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots prevent heat from convecting, resulting in cooler regions on the surface. Despite these cooler spots, Betelgeuse is still a massive, active star that will ultimately explode in a spectacular supernova. Betelgeuse is a massive star that is nearing the end of its life. When it runs out of fuel, it will go through a drastic process of fusion that turns heavier elements like carbon and helium. This will probably cause the star to expand to much larger sizes, making it one of the largest stars in the night sky before it dies in a cosmic explosion. A devastating explosion that signals a big star's demise. A supernova's strength is sufficient to momentarily eclipse the whole galaxy. Scientists are closely examining this phenomenon in the hopes of learning more about the future of stars and the evolution of the universe. As Betelgeuse approaches the end of its stellar life, astronomers are closely monitoring its behavior because it is predicted that the star will eventually go supernova. This phenomenon could potentially send shock waves through space, and it is possible that Betelgeuse will undergo such an explosive end very soon. An explosion that will cause its outer layers to be ejected into space, leaving behind a dense core that, depending on its mass, might either collapse deeper into a black hole or become a neutron star. A supernova is a catastrophic occurrence that marks the end of a star's life cycle. Given its extreme brightness and close proximity, Betelgeuse's eventual supernova could be seen from Earth without the use of a telescope. This explosion would release enormous amounts of energy, producing heavy elements like iron and nickel that are necessary for the formation of planets and other celestial bodies. These elements would be dispersed throughout the universe, enriching the interstellar medium and helping to create future generations of stars and planets. It's interesting to note that some researchers have proposed that Betelgeuse may explode as a supernova within the next 100,000 years, which is a short time span in the universe's history but still too far away to pinpoint precisely with the James Webb Space Telescope. This is because scientists have been able to detect strange fluctuations in the star's brightness in recent years, leading to speculation that the star may be on the verge of a supernova. Scientists can now examine the star's outer layers and magnetic fields in unprecedented depth because to JWST's red capabilities, which have also helped establish the star's continuous changes, including as their uneven brightness and possible instability. These discoveries provide important insights into the mechanisms behind a star's demise, improving our comprehension of stellar evolution. The demise of Betelgeuse will have a profound effect on the cosmos because the supernova shock wave may cause new stars to form nearby, extending the cycle of star birth and death. In addition, the elements created by the explosion will disperse throughout space, helping to create the building blocks of new worlds in the larger scheme of cosmic evolution. Even if we won't be there to see the star's last moments, Betelgeuse's death will not only signal the end of one of the largest stars we can see, but it will also open the way for the next generation of celestial objects. The study of Betelgeuse gives astronomers important insights into the life cycles of stars and the dynamic nature of the universe. It also gives them a better understanding of the processes governing the birth, life, and death of stars and provides a window into what will happen to other stars with similar traits in the future. With the use of cutting-edge technology and space observatories, researchers intend to carry out further research on Betelgeuse. Our knowledge of astrophysics will be further shaped by the data collected from the star, which will enable us to solve the puzzles of how stars change over time and the implications of their cataclysmic deaths for the cosmos. While Betelgeuse's death is inevitable, it's important to keep in mind that the universe is always changing and evolving, with new stars being born all the time. The energy released by supernovas like Betelgeuse will ensure that the cycle of life and death in the cosmos continues. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe and gain a better understanding of the forces at work in the cosmos and our place within it. We are reminded of the vastness and complexity of space and the amazing processes that shape the universe we call home.